Let's see what you've learned today. Question number 1. How is rotational speed defined? So rotational speed is going to be omega, and omega is going to be equal to how far does it rotate, so the angle through which it rotates in a certain amount of time. So that's the definition of rotational speed. Number 2, a small wheel and a large wheel spin at the same rotational speed. How do their linear speeds compare? Okay, so we got a small wheel, which means it's going to have a small r, and then you've got a large wheel, and so this one's going to have a big R, and they're both spinning at the same rotational speed. So let's say that the omega is the same size. So if they both have the same rotational speed, the omegas are going to be the same. Okay, what was the connector between linear speed and rotational speed? It was the R. And so we said that linear speed v is going to be equal to rotational speed times the radius, and then over here it's the same thing. So that this is also going to be equal to v. But notice, if this is a small r, that's a small v. If this is a big R, this would be a big V. So therefore, the large wheel is going to have a greater linear speed than the small wheel. Number 3, what variables does rotational inertia depend on? So we're back to here, and the definition of I is it's some number, and then it's times m, and then r squared. So that's our definition of I. So it's going to depend on the mass, it's going to depend on the radius, and it's also going to depend on where is the mass. So is the mass on the outside or is it on the inside? It also is going to depend on the shape of the object. Is it a cube that's rotating, or is it a wheel that's rotating? So it depends on quite a bit. Number 4, how are torque and force related to each other? So torque and force. Well, the connector is R. So torque is going to be equal to a force multiplied by the radius. Number 5, why is a tail rotor necessary for a helicopter? So we said that the engine on the helicopter exerts a torque on the blade to make the blade go around and around. So according to Newton's third law, the blade exerts a torque on the helicopter, which would make the helicopter rotate in the opposite direction. But you don't want that. So in order to keep that from happening, you put a tail rotor on your helicopter, and that provides a counter torque to counter the torque of the blade on there. Number 6, what does conservation of rotational momentum mean? You can't create or destroy rotational momentum. So whatever momentum you start with, that's the momentum you got to end with. So if you're an ice skater and you got your arms out like this and you're rotating around, you could calculate your angular momentum. You could calculate it, and that's a number. Let's say it's 100. Okay, when you bring in your arms, you could calculate your angular momentum, and it would turn out to be the same number, 100. So whatever momentum you start with, that's the momentum you have to end with. So that's conservation of momentum. Number 7, What variables does rotational kinetic energy depend on? Okay, so rotational kinetic energy is given by E, and notice they both have the same unit. So this is linear kinetic energy. This is rotational kinetic energy, but it's energy. Energy's energy. So the unit for energy is J for joule. So the kinetic energy is going to be 1/2. Instead of M, we put I, and instead of V, we put omega squared. So it's going to depend on whatever the moment of inertia of the object is, and it's going to depend on how fast is it spinning. Well, that's it. So in our next lesson, we are going to talk about gravity. I'll see you then.